Hi class, today we're going to talk about similar triangles and proportional reasoning. Just a quick review of back when we were doing um, ratios and proportions. A ratio is a comparison of two quantities with the same units. When the two ratios are equivalent, they're called a proportion. So a ratio is written like this. So we have 1 to 2 is equal to 5 to 10. This is equivalent to what we've written here. Now, when we're solving a ratio, let's say we have a fraction like this, a over b is equal to x over y. We can use cross multiplication. So we're going to take the top and multiply the denominator of the other side. And once again with the other one. So we would have ay is equal to bx. The advantage of doing this is so that we have no more fractions to deal with. And cross multiplication, I don't usually talk about cross multiplication. The only time that you can do it is when you are using ratios. Now let's use cross multiplication to solve for the x in these ratios. Part A, I have x over 5 is equal to 6 over 7.5. Now, because this is a ratio, I can write it like, I can write it like this and then cross multiply. So when I cross multiply, I have 7.5x is equal to 6 times 5. Let's continue. 7.5x is equal to 30. And then we have 30 divided by 7.5. X is equal to 4. So we've solved for the value of x. We know that if I have 4 over 5, this is equivalent to 6 over 7.5. Let's do part B. Part B, we have 7 and 9 is equal to 98 to x. So since this is written in ratio form, we can rewrite it as a fraction. Now notice that we need to line things up. I'm going to write the first number on the top and the second number on the bottom. For our second ratio, we're going to do the same thing. 98 comes first, that's on top, and we have x on the bottom. Now we're going to cross multiply. So 7x is equal to 98 times 9. Let's continue on. 7x is equal to 882. And then we divide both sides by 7. And we have x is equal to 126. Okay, so for both of these, I could rewrite the original statement. 7 to 9 is equal to 98 to 126. Or the first one, we can write it like a fraction. We have 4 over 5 equals 6 over 7.5. Great. Just a side note about the naming convention for triangles. When we're talking about triangles, one of the main ways that we talk about angles is using capital letters. So I have capital A, capital B, and capital C. The sides that are across from these, so for example, this side is across from angle B, we have side B, and it's represented by little b. Now we can do the same with A. This is little a, and the side across from C is little c. That's one way we can name our sides and angles. Another way is to use the actual angle that it's created. So let's say I'm talking about angle A, and I use this little symbol for angle. I could also say this is equivalent to angle BAC. And what it's saying is we're going to start at B, goes to A, and ends at C. And that creates my angle A here. An alternative way to talk about our sides, we could say that, for example, little b is equivalent to the side that's made up of the line between A and C. So we could use AC, and those would be equivalent. Similar triangles. For triangles to be similar, corresponding angles must be equal. Now, what I'm saying corresponding angle, I have angle A is equivalent to angle D. Angle C is the same as angle F. And if I know that these two angles are the same, it follows that my third angle is also going to be the same. The reason I know that is because all triangles add up to 180 degrees. So if two of them are already the same, then the remaining one will be the same difference. Now what we've done here, we've said that angle A is equal to angle D. Angle C is equal to angle F, and angle B is equal to angle E. Now, if all three angles are the same, then we can say that the triangles are similar. We use this squiggly line as a symbol to represent similar. So I'm going to write triangle ABC is similar to triangle DEF. Now, if the triangles are similar, then all of the sides are also going to be in proportion to each other. We have this side AC. This is in proportion to the side DF. AC over DF. And this is going to be equal to the ratio created by CB and FE. And all of that is also going to be equivalent to the ratio created by AB and DE. There are three ways to tell if two triangles are similar. Now, we just talked about our first method. If all of the corresponding angles are equal, then the triangles are similar. So short form, angle, 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 then it makes it similar. Right, a second method If all of our corresponding sides are in proportion to each other, we also know that they are similar. So we could use side, side, side is similar. So when I talk about the corresponding sides, I mean this fraction here. If I can get AC over DF, CB over FE, and AB over DE, I'm comparing all of these sides. They create the same ratio, then the sides are in proportion. Okay, method 3. If I have two pairs of corresponding sides that are in proportion and the angle contained is equal, then I also know that it is similar. Let me draw a diagram to illustrate this. So let's say I have a triangle that looks like this and a larger triangle. If I have the angles at the same degree, let's say this is 30 and 30, and my sides are in proportion to each other. You can tell that these two are in proportion. This is 3 times as large as the original one, and then 8 times 3 gives you 24. Then we know that these two triangles are similar. Now, what this one, we would use the symbol side, angle, side, and that makes it similar as well. Great. Example number 1. Show that triangle PQR is similar to triangle MON. Then find the scale factor that relates the lengths of the triangle PQR to MON. Well, first of all, we have no angles here. So the angle, using angle, angle, angle doesn't work. But we could use side, side, side to see if all of the sides are in proportion to each other. My guess is that PQ is similar or is in proportion to MO. PQ, or sorry, QR and ON are in proportion, and the last one is also in proportion. So let me set up my ratio. I would have PQ over MO. This should be equal to QR over ON, and it would be equal to PR over MN. Now, when I substitute the numbers in, if all of the numbers are equivalent ratios, so they all equal each other, then I know that this is a similar triangle. Let's do the first ratio, PQ over MO. This equals 12 over 15. And simplified, 0.8. Let's do the next one. Second ratio, we have QR over ON, 9.2 over 11.8, 11.5. That simplifies to 0.8. Okay, so far everything is in proportion. Let's do the third one. Third one, PR over MN, 11.6 over 14.5. That works out to 0.8. Now, since this was proven, I know for sure that these two triangles are similar to each other. Okay, so since PR or PQ over MO equals QR over ON is equal to PR over MN, we know that triangle PQR is similar to triangle MON. Now, what we've done here is the ratio is actually the scale. So if this was our whole, this triangle is 0.8 times the size. So our scale factor, triangle PQR is 0.8 times of MON. I'll put a little note here. The ratio tells us the scale factor. Next example. Elliot's employer is asking him to find the height of a tree. He measures the length of the shadow of a meter stick to be 1.3 meters, and at the same time, the length of the shadow of the tree is 14.8 meters. Find the tree's height to one decimal place using similar triangles. Draw a diagram. Now, first of all, I'm going to draw a diagram of the tree. So we have a tree here. We have a sun that's shining down on the tree. So it creates a shadow, and we know that the shadow gives us 14.8 meters. The next thing we know is we know that there's also a meter stick. So I'm going to draw this separately. Somewhere else, he put a meter stick. The meter stick is just 1 meter long. But once again, the sun is shining on it. Okay, so when the sun shines down on it, we have a shadow of 1.3 meters. We also know that by virtue and by definition of a meter stick, that my stake here is 1 meter. A couple of things I need to show. If Elliot wants to use similar triangles, he needs to show that there is one angle and two sides that are the same, or he has to show that three sides are in proportion to each other, or he has to show that three angles are equal. I think here, because we only have two sides and this one only has one, we're probably going to aim to use the angle, angle, angle. So first of all, we have a right angle that's created by the tree and the ground. The stick in the ground also creates a right angle. The sun is shining down at the same angle. Now, we can make that assumption because the sun is really, really far away. And so by the time it reaches here, the tree and the stick, even though it is not right beside each other, we're going to have the same angle. I'm going to use an X to represent this angle is the same. And if I have two angles that are the same, I know that my third angle must also be the same. Now, because these triangles are equivalent or are similar, I can use ratios to help solve for my height of the tree. I'm going to represent the height with the letter H. Let H be the height of the tree. So I'm going to take the height and the shadow. H over 14.8 is equal to height of the meter stick over the shadow. Let's cross multiply. 1.3, so we have 1.3h is equal to 1 times 14.8. Now you don't have to write that one if you can see it. H is equal to 14.8 over 1.3. And we have H is equal to 11.4. So we used similar triangles to set up this ratio to find the height of the tree. Right, another example. We need to prove that ABC is similar to DEF. Solve for CD and CE. Now, just a quick recall. You may remember that when we have parallel lines, we have a couple of things that we know. Okay, so let's say these two lines are parallel. If these two lines are parallel, we know that the angle here and angle here is the same. I call this the Z pattern because if my parallel lines create the letter Z, then we know that these two angles are equal. Now, another one, if I have parallel lines, I can say that I know the angles here and here are equal. And this is called the F pattern because it looks like the letter F. I have here right? So just to give you a reminder, these are two parallel line patterns that we know, and we know about these, and that's going to help us solve for our angles. So in this case, I have three sides here, and on this side, I only have one side. That's not helpful for us to find out whether these are similar triangles, but if we can prove that all the angles are the same, then we can say that these are similar. Right, parallel line here and here. Let's use the Z pattern. We know that angle A and angle D is the same. We could say again using the same Z pattern that angle B and angle E is the same. And if I know that two angles are the same, this last one also has to be the same. All right, we have now determined that triangle ABC is similar to triangle DEC. Now notice that angle A, I used a blue dot. I need to start my second triangle statement with the same one. So I have triangle D and then the red EC. Okay, so since these are similar triangles, we can create a ratio. I can solve for the sides using ratios. Let's write the statement. So I have AB, this side here, is equivalent, or yeah, is in proportion to DE. The next one, AC, is going to be in proportion to DC. And the last one, BC, is going to be in proportion to CE. Let's put in the values. 3.6 over 5.4. This is equal to 4.1 over BC or CD. Okay, just for simplicity's sake, I will call it CD instead. Same thing. And finally, we have BC 4.5 over CE. Now, this statement has two unknowns. We can't solve two unknowns at the same time, but I can do two of them. So I'm going to first take these two, and then when I solve that, I'll take the last ratio and the first ratio again. Okay, so first one, 3.6 over 5.4 equals 4.1 over CD. Let's cross multiply. 3.6 CD is equal to 4.1 times 5.4. Let's keep simplifying. 3.6 CD equals 20.14. Let's divide both sides. And we have CD is equal to 6.1. 0.15. Right, that's one of them. Now for the second one, we'll do this one and the first ratio. 3.6 over 5.4 equals 4.5 over CE. 3.6 CE is equal to 4.5 times 5.4. 3.6 CE equals 24.3, and when we simplify it, we have CE is equal to 6.75. We've solved for this using our ratios, and before we used the ratios, we had to use our Z pattern and F patterns or whatever patterns we needed to show that the angles were all the same so that we can say that these are similar triangles.